Alright, the moment we've all been waiting for, shell scripting. I'm so excited about the beginning of our shell scripting that I can barely contain my excitement. And why am I excited? Because I love shell scripting. That's it. I'm not afraid to admit it. I love shell scripting. It allows me to automate almost anything. Uh, so, I'm not iTunes. I don't like doing things over and over again manually. If it can be done at the Linux or Unix command line, then it can be scripted. So if there's a task that can be scripted, it will be scripted, and it may take you longer to script it the first time than it would to do it one time. But if it's something you're going to be doing repeatedly, then you're going to script it. Even if it's something you're going to be doing one time, once you get competent, then you'll script it. So we have some slides, and we'll break off to the prompt to do some stuff as we go along. First thing we want to talk about is the components of a shell script as our book references them. Most of this information will come from Chapter 6. Our shell script will need three different things that we have: shell variables, shell script operators, and logic structures. So a shell variable will store information in memory for use by the shell script. We'll reference those variables. We'll look at the contents of those variables to make a logic structure decision, and we'll just use variables a lot. Variable is a symbolic name. It consists of letters, numbers, and characters. Letters and numbers and characters. So space is not one of those things. So you must have a contiguous stretch of letters, numbers, or characters to make a variable name. References the contents of the variable. So when you use a variable, you will be trying to get the contents of that variable out. And the name you give the variable should reference the variable's purpose or contents. Shell scripts support many shell script operators. Those operators include operations for assigning the contents of a shell variable, for evaluating information, for performing mathematical operations, and for piping or redirection of input. And then finally we have logic structures. We have sequential, decision, looping, and case logic. These are also called control structures. These are the things we'll be doing if statements to check for particular values we're looking for. We'll be doing for loops. We'll be doing while loops. We'll be doing some case statements for fun to make our programs do what we want them to do. Book goes through the program development lifecycle. It says you should have a process to develop your application. Step 1, create program specifications. Probably the most useful thing in this for our purposes would be to write a little bit of pseudocode, if you will. Pseudocode is when you write what you want the code to do, but not necessarily write the code yet. Step 2 says begin the design process. If you're doing some sort of complex application where you're actually writing something that users will be using, they're going to be inputting text or using some sort of menu-driven program, then yeah, you'll want to do that. Most of the time as a system or application administrator, you may be just writing scripts for your own purposes, so the design process isn't really that important because you're just going to be writing a script to do something that you already know how to do. Step 3 says write the actual code. Step 4 says test and debug. I will argue that Step 3 and Step 4 go hand in hand because I actually write and test and debug code as I go. The idea that you're going to sit down at Step 3 and write a full application and then run it for the first time once you're done. And when I say application, I mean even just any basic script. The idea that you're going to write a script and run it when you're done is a fallacy. I don't think anybody that writes scripts actually does that. I know I debug along the way, and I'll show you some of that as we go along. Shell script. What is a shell script? It contains a sequence of commands. So basically all those commands we've been learning about, we're going to ram those together to do some specific things. We're going to ram them together with some variable usage and some control structure to take care of some things. The script is interpreted by the shell, so the shell interprets your commands. It is not compiled. Our normal binary programs we write in C or C++, we compile it with a compiler, and it generates a binary file of machine instructions. So shell scripts are not that way. They're interpreted by the by the shell. Says it must be identified as an executable file, so in order to execute that file, you must make it executable using the chmod command that we talked about before. After it's executable, it can be run in several ways. You can just enter the name at the prompt if the path variable is set. We'll talk about that in a second. You can precede the name with a /, which is what we've been doing so far, or you can provide an absolute path to the file. And it says down there that interpreted programs are not as fast as compiled programs, and that's true because you have extra steps involved. The shell must read the commands and then execute each of those commands individually for a shell script. But with a compiled program, the compiled program is written directly into the machine code that the machine can execute. So it's a good place to stop for now. Let's go look at our terminal window. The first program you always write in any program language is the Hello World program. So we're going to write Hello World. Hello World.sh. .sh is not required. That's just a convention most people use when writing shell scripts to let you know that it's a shell script. When you write it, I very easily could write Hello World, put some shell commands in there, and execute it, and it would work fine. But I'm going to put a .sh on there. First, so for this, it's going to basically echo Hello World. And that's it. So we look at the permissions. It's read, write, and read. It needs to be executable, right? So the slide said give everybody execute. I don't give everybody execute. I'm only going to give the user execute because I'm the only one that's going to execute my commands, right? The file said there were 3 ways we could run it. We could enter the name at the prompt. This isn't going to work right now. This isn't going to work. It's going to say command not found, I hope. Yeah, command not found. And that is because if you do not specify a full or relative path to the command, then it will not execute unless that command can be found in the path. So you have an environment variable called your path, which anytime you type just the name of a command, it looks in the path for that command. So if we just type date, right? We didn't provide a full or relative path to the date command, but if we find out where date is in bin. And if we look at our path, we have user local bin, we have bin, so it found it there. So it was able to run it. My Hello World script is not in my path, so I can edit my path by essentially saying path equals $path, and then put a colon. Notice it's colon separated, and then I can put my current directory, which is going to be home ec2-user/mod5. That's the directory I'm in. In the real world, you probably wouldn't do this for just any directory, but I'm going to do it for now for fun. So that's my path. So now, in theory, if I run my script, maybe it'll work. Yeah, so there I ran it without specifying because it was found in my path. Hope that makes sense. Another way, the way we've been doing it so far, the way I normally do it, I normally don't modify my path. I just use / to run it. / hello world will run it. We could also specify a full path, right? Just like I put this in my path variable. I could also put, what just happened? I could also put that in front of my command and run it that way. So that's the 3 ways you can run the command, and that's also making it executable so we can run it. So let's go back to our slides and see what else we need to talk about. All right, we covered all that. Comments begin with a $sign. In theory, you should put comments in your code so that somebody who comes along after you can know what your code is supposed to do, and that someone could include you. I will confess I'm not the best at putting comments into code. In fact, I almost never do it, and I have spent more than a few minutes or hours even reviewing code I've written to figure out what it was doing. So comments are a good idea. You should do it. I usually don't. I'm not a good example to follow for that. So anyway, anything that starts with a pound sign is a comment. Here's some examples when you might want to comment. You might want to add a little header. If we look at this back here, we had a header. It had the name of the script, who wrote it, the date, what it was for. You might want to include like revisions, like a version number 1.0 in initial version, and then when you modify it, make it version 1.1. You know put in what you modified. So, that's not what I'm going to do. So some other things: modification date and purposes, purpose and types of variable used, files that are accessed, created or modified, how logic structures work, purpose of shell functions, how complex lines of code work, reasons for including specific commands, all that stuff. So let's go back to our hello world script and put some comments in there that I never do. Right? Sorry. So name hello world created by Rich, created on 12, oh, I think it's December, what's today, the 14th, 13, then I want to put purpose, print hello world. So there we go. There's some basic comments in my script. Pretty exciting. Just for fun, we'll go run it again because it's still going to run, right? Those are all scripts. Those are all comments, so that doesn't matter. All right. Environment variables. Let's talk about variables. You have variables. Some variables are already set up. Environment variables get set up when you log in, and path is one of your environment variables. These are all the environment variables that are set for you by default. They get set up by your session when you log in, so there's no reason for us to really worry about much of this. Most of that stuff, not anything we really need to worry about. Other variables are shell variables. So if I want to, shell variables. Shell variables are variables that will be used within your shell. We'll go through some examples in a minute. You can create them at the command line. You can use them in your shell. So let's go back to my slides. Basic guidelines for handling shell variables. Omit spaces. I said that before. You can't have any spaces inside your variable name. You also can't have spaces inside whatever you're assigning to the variable unless you enclose it in double quotes or single quotes. To reference a variable, put a dollar in front of it, $sign in front of it. You can use the square brackets for arrays. Export a shell variable to make it available in other scripts. To make the shell variable read-only, use the word read-only. I don't ever use read-only shell variables as far as I know. Avoid using $sign in the name because that can be confusing when you're referencing it with a $sign. Use descriptive names. So I don't do that a lot, but you should use names that describe what the variable has in it. Use capitalization appropriately and consistently. So if you're using all caps, if you're getting somebody's address, you get their street, their state, their city, their zip code. Use all lowercase for all of them, or capitalize the first letter. What you don't want to do is use lowercase for street, uppercase for state, lowercase for city, uppercase for zip code. Uppercase, like you have uppercase numbers. That's silly. If a variable name consists of two words, put an underscore between them so you can't have a space in the variable name. I said that before. So let's go look at some examples of variables. So if we want to set a variable, I'm going to do this as a command line, but it will work the same way in a script. Name equals Rich. So when I set the variable, I put the name of the variable without a $sign. When I reference it, if I just type echo name, what's that going to print? That's going to print the word name. I need to put the $sign to reference, oh yeah, I want the contents of that variable. So now it says rich. If I put the variable in double quotes, right, it prints rich. If I put the variable in single quotes essentially says ignore the specialness of the variable. So single quotes doesn't extrapolate the contents of the variable, it just puts the variable itself. So that was just plain rich. Say I wanted to set my name to Rich Elwell, right? It says name equal Rich Elwell, and then I get an error that says Elwell command not found. And if I echo name, it just says Rich. So if I want to put a string inside there, I need to enclose that string in double quotes to protect the space. I think single quotes will work as well. Yeah, so single quotes worked as well for that. If you wanted to have a variable with two words, you could do it like this. Right, and you can echo $first name, $last name. Right, so that printed out the contents of the two variables. If I wanted to put some text in there, right, Rich, first name, last name is the best, then I'm going to get it to print out that way. You can also, just to be safe, put double quotes around the whole string to print it all out. So that's that. What else about variables? That's all I want to say about variables for now. So shell operators, let's not talk about that yet. So we're going to go into our hello world script, and we're going to revise it, version 1.1, put hello world into a variable. So just for fun, we're going to set a variable called print string equals hello world, and then we're going to echo print string instead of hello world. These values are case sensitive for variable names, so capital P RINT string and lowercase p RINT string are not the same. What happens if you put lowercase? Well, let's run it and find out. It's going to print nothing because the variable is empty. There we go. So now the variable is empty. So anytime you echo any variable has nothing in it, it just prints a blank line because the default action of echo is at the end it prints a new line. So now if we echo print string, do hello world, we echo the print string, it printed our hello world. So that is basics of how to assign a variable to the output of a command to a variable. So let's go look at these operations right quick. Shell operators. Basic shell operators are divided into four categories, four groups. Defining operators, that's where we set a variable. Evaluating operators, we'll use those when we are controlling our loop structures. If something equals something else, or if something doesn't equal something else. If something is a file, we'll get to that later. Arithmetic and relational operators. If something is greater than, less than, equal to, doing some addition type things. Redirection operators. That's we put the input or the output to another file. Defining operators. You can set names. I did that. This third one here, I did both of those. Set a name equal to a value. Set a name equal to a value with spaces in it. You need the quotes. This last one down here, where you have a command inside of backticks, that will set the variable equal to the output of the command. So if I set a variable equal to ls output and do backticks on my keyboard is over above the tab key. It's the same key that has the tilde on it, so that's where you will find that. So ls output equals ls. That says run the command and put the output in this variable. And then if I echo $ls output, you'll get the actual ls command. I use the backticks all the time because pretty much every script I write needs to get some information from somewhere to process. And I get that information either by reading a file or pulling usernames out of the Etsy password file or doing an ls of a directory to see who's done their homework. So that is probably one of the more important things you should remember, that you can use the backticks to run a command. So let's put that in our hello world script. So we want to modify hello world to print the date. So we're going to set date today. Look at that descriptive name. Today equals date. So we're going to run the date command to get today. And then we're going to echo, we'll put some double quotes for fun. No, I'm not going to do that. I'm going to leave that like it is. I'm going to put another line. Echo today is $today. So now my script's going to print hello world and tell us what day today is. So hello world. Hello world, today is Thursday, March 14th, 12/12/34, Eastern Daylight Time, 2013. So that was a quick modification. Let me go update my version 1.2. Echo print the date. Print today. Wow, look at that commenting. That's awesome. That was the assigning values. Let's see what else our slides say. We did that already. If you echo $name without double quotes, it will print it. If you echo $name, when I say it will print the contents of the variable. When you echo $name with double quotes, it will print the contents of the variable. When you echo $name with single quotes, it will print $name. Some arithmetic and relational operators we'll be using later on. Pluses and minus denotes positive and negative values. Logical and bitwise negation for the pound sign, and not the pound sign, exclamation point and tilde. Multiplication, division, remainder, star, slash, and the percent. Addition and subtraction, greater than, less than, and then equals and not equals. So we can use those when we are adding things or comparing things. So here is an example using let to do some arithmetic within a variable, within a script or at the command line. So this example says let x equal 6 plus 4 times 2. So, and then you can echo out the x value. You can use this in scripts. I actually use that in my PID script we saw when we were talking about processes. I'll show you that in a second. So essentially, this follows the normal mathematic precedence. So it's going to do the 4 times 2 first, and then add 6 to it. So for my PID file, that's not it. Oh, I had another file I didn't show you guys. It was a suicidal file. Kill. No, I didn't need to show you that one. Never mind. Forget you saw that. Endless loop. My endless loop command, I use let to increment the value of I. If you remember the endless loop command, it ran and these values incremented by 1 every time it printed out. So the way I did that was by saying let I equals I plus 1. I set I, initialized I to 1, and then I used let to increment it as it went along. So I did that. I'll go ahead and show you my kill endless loops script. Basically, I just modified this to put an if statement in. if $I equals 10,000, then echo killing self. And I put a kill command in with the $2 signs because $2 was a process ID, remember? And then it will kill itself after it runs 10,000 times. So if we watch that, bam, it killed itself. So that was an example of an if statement. I don't think we're ready for that yet. All right, let's see what other slides I have. Shell variables. Oh, let. I just talked about let. Scripts cannot automatically access variables created or assigned on the command line or by other scripts. You must use export first. So let's go do an example of that. So I have my PID file that printed my PID.sh printed $, which was a process ID. So let's create a new file called print name.sh, and we're going to make it print the name, right? So if I echo $name, I have Richello in there. If I run, what the? Oh. If I run this command now, it says that it should print name, right? I just wrote that. It should echo out $name. So if I run this command, it should print name, right? Oh, there's nothing there, but how come? Oh, I'm so confused. Well, remember I told you in the processes podcast that the current shell runs the commands in a subshell. Well, like that slide just said, those shell variables are not available to other shells unless you export them. So if I type export $name and now I run it, that didn't work. And now I'll run it, it prints it. So when you export, you don't include the $sign because that references the contents. You include the actual name of the variable, export name. And now when I print name, it prints because that shell variable was exported. Okay, so do you need to worry about that? Most of the time you don't, but if you are going to be, from your shell script, calling more shells to do extra things, like from within your shell script, you could launch another shell. If you want that shell that you launch to have access to the variables that are set at the time they're launched, then you need to export all those variables that you want to have access to. So that's that. Let's see what else I got.